So let's talk about specific heat. Specific heat is a particular quantity of heat. Let's imagine some gold. So here's some gold. If I want to know how much heat it takes, it's 0.129 joules of heat to get a gram of gold to warm up by a degree. Here's some granite. Granite's harder to heat up. It needs 0.79 joules to get 1 gram of granite to warm up by 1 degree. Those are specific heat values. So now let's heat up some water. Here's a hot plate. I'm going to put a coffee pot on, and I'm going to fill it with water. In this pot, I'm putting 820 grams of cold water at 12 Celsius. Water's hard to heat up, 4.184 joules to get a gram to warm up by a degree. If I put 196,000 joules of heat into this water, how hot will it be? Well, Q equals mc delta T, so we can solve that for delta T, the change in temperature. Delta T is Q over mc. My Q is 196,000 joules, and I divide that by 820 grams times 4.184 joules per gram Celsius, and I get 57.1 degrees. That's not the temperature at the end, it's the change in temperature. Add that to the initial. What if I don't know a substance's specific heat value? But I do know what happens when I add heat to it. Here's an unknown substance. Now I'm looking for C. I want to know the specific heat from the Q equals mc delta T. Well, imagine that I put 1200 joules of heat into 220 grams of it, and it warms up from 21 to 35. That's a delta T of 14 degrees. C is Q over m delta T. So the specific heat is 1200 joules of heat divided by the mass, 220, times the delta T, 0.3896 joules per gram degree Celsius.